Input n equals 4, target output 1211. What would you do next? We are not inventing digits from nowhere. We start at 1, then keep describing what we see. Show the chain for this example. 1 becomes 1 1, then 2 1, then 1 2 1 1. Pause here. Read 2 1 out loud. 1 2, then 1 1. Say what you see, and you get 1 2 1 1. So the job is really this. Start from 1, repeat that describing step n-1 times. Take a second. If you had to code the describing step, what would you try first? The obvious approach is, for each character, count how many same characters continue, write that down, then jump ahead. That works on 2 1. But watch what happens on 1 1 1 2 2 1. If you restart counting from every position, you repeat work. And if the run is long, that waste gets bigger. We already knew those first 3 ones belonged together. So what information do we wish we kept while moving forward, instead of rediscovering the same run? We only need 2 things, the current digit and how many times we have seen it in this run. That is run length encoding. Think of a line of matching beads. We just say how many of one color appear together. And here's the move. Walk left to right once, grow the count while digits match, then flush the run when it changes. Same rule, shorter words. Keep counting the current run, and only write when the run ends. You might think we can stop at the last change. Watch out, the final run never gets written unless we handle it after the loop. So the bug-preventing rule is simple. When the scan finishes, append the last count and digit one more time. Let's trace n equals 4. We start with the current string set to 1. First build step. 1 1 is 1 run, so the next string becomes 1 1. Second build step. In 1 1, we see 2 1s together, so the next string is 2 1. Third build step. In 2 1, the digit changes immediately, so we write 1 2, then 1 1. Now we have done 3 describing steps, which is n-1, so 1 2 1 1 is the answer. Notice what changed. We never recounted a finished run. Each character was handled once in that pass. For each describing pass, the time grows with the string length, and the new string also grows with that length. Let's write it. First, keep 1 in current, then loop exactly n-1 times because the first term already exists. The helper does the real work. Pieces collects the answer, and count tracks the run we are inside. As we scan, matching digits increase the count. A change means append count and previous digit, then reset. Then we append the final run after the loop, and join the pieces into one string. Good. 1 pass per term and each pass just counts runs.